Hello dear friends, myself Sonigra, and today in the subject of mechanical drafting, we are going to discuss a chapter titled as Projections and Sections of Solids. Previously we discussed the basic theories related to projections and sections of solids. Today we will discuss some more examples and some elementary steps to find out the true shape and sectional views of the solid. The objectives for today's discussion covers: the first is to draw various views of basic solids based on given condition, to understand various positions of cutting plane, and to draw front view, top view, side view, and a true shape of the sections as per given position of solid. So these are the objectives for today's presentation, and the examples, the first example for today's discussion is like this. A triangular pyramid 50 mm side of base and 50 mm height is resting on HP on its base such that one side of the base is perpendicular to vertical plane. It is cut by an auxiliary inclined plane inclined at 30 degree to HP and bisecting the axis. Draw the projections of the solid. This is a triangular pyramid as represented over here. This is having 1, 2, 3 and 4 triangular faces, and length of each triangular face is given as 50 mm. So this side length of this triangular base is 50 mm and height is 50 mm. So length of this slant edge will not be 50 mm. The height is 50 mm. It means that the distance from this triangular plane, this bottom plane, and this apex point is 50 mm. So how to draw this problem? So first we write the data in a small form like this: a triangular pyramid 50 by 50 on HP, AIP 30 degree to HP and bisecting the axis. So first of all, draw an XY line that represents intersection of both the planes HP and VP, and draw its top view. If you look from the top to this triangular pyramid, it will appear as a triangle of side length 50 mm, and as it is given that it is resting on one of its triangular face, we have to draw its top view like this, in such a way that one side is perpendicular to XY line. So this distance is 50, and by taking 50 mm as a radius, draw an arc taking both these ends as a center, and both these arc will cut at one point, that would be somewhere here, and join these 3 points with a straight line. Then find out the axis of this solid. So for that, join the corner with the midpoint of opposite side. For example, midpoint of this side is this one and opposite corner is this. So join them with the straight line. Similarly, join this corner with the midpoint of this opposite side, and both these lines will intersect at this point, and this point represents the position of the axis of this solid. So from this point, draw an axis like this, or a dashed center line, means one long dash, one small dash. So this represents the axis of this solid. Then height is given. So at a height of 50 mm from this axis, take projections from these ends, and at a height of 50 mm mark a point on this axis and join this point to these projected lines and join with a straight line and make a triangle like this. So this triangle represents the front view of this solid. Now this is a cutting plane. Here it is given that the cutting plane or auxiliary inclined plane inclined at 30 degree to horizontal plane, means we have to draw a line which makes an angle of 30 degree with XY line, and it bisects the axis. So this cutting plane line will pass through the midpoint of this axis. So first of all, find out midpoint of this axis, that would be somewhere here, and from that point draw a line at an angle of 30 degree with XY line. So this line represents the auxiliary inclined plane or cutting plane line. Now we have to draw its true shape for the sectional view and sectional top view. So for that, they find out the points of intersection between this cutting plane line and slant edges. You can see here two slant edges are there, this one first and second, and here one slant edge is there, this one, right? If you look from the top, these three triangles, this one can be represented by these slant edges, which meets at this center of gravity or at the axis position. Now from this point, you can see here the point of this intersection of this cutting plane and this slant edge. Two slant edges are there, so 2 points are here. So from this point, draw straight vertical line that will cut the first slant edge at this point and the second slant edge at this point. So these two are the points over which represents the top view of this cutting plane, and from this point the intersection of this cutting plane and this slant edge is here. So from that point, draw a straight vertical line that will cut this slant edge at this point. So these are the 3 points. Join all these 3 points with the straight line. It would be a triangular shape. So this triangle, this filled by this pink color, shows the sectional top view of this triangular pyramid, and this portion is removed portion. So either you should remove this one or make it much lighter. So this is the front view for this triangular pyramid if it is cut like this, and this represents the top view, or it is called as the sectional top view of this solid. And you can erase these lines, and let me draw this problem in our drawing sheets. So how to draw the solution of this problem? Up till now we have drawn up to this step: triangle below XY line and front view above XY line. Now here its slant edges would be like this, which represents its top view, and cutting plane is given, which makes an angle of 30 degree with horizontal plane and passes through midpoint of the axis. So you can draw this cutting plane like this, and here solid is cut, so it could be represented by solid line, and this is a cutting plane line which is represented by which we are representing here with the red colored line, one long dash, two small dash, and so on, right? And here this is the midpoint of the axis. So how we have located this point? This point is located at a distance of 50 millimeter from XY line. You can insert this dimension. This dimension is 50 millimeter, sorry, 25 millimeter, as 50 millimeter is the axis. So this is 25 millimeter. You can insert the dimension 25, 50 is the height, and from this point a line is drawn at an angle of 30 degree with XY line. So this angle is 30 degree. Now find out points of intersection of this cutting plane and this slant edge. So here 2 points are there. So from this point, draw a straight vertical line that will cut both these slant edges in the top view. One point over here, another point is over here, right? Similarly, from this point, draw a straight vertical line, and this straight vertical line or projection line from this point that will cut the top view of this slant edge at this point. So 3 points are there. Join all these 3 points with the straight line, which is triangular in shape, and as it's a triangular pyramid, straight line would be there. Here this internal portion is removed, so you can erase these slant edges over here, as it's now it is a flat portion, and here this would be visible. So you can draw here straight lines up to this end only, right? And this is, as it's a sectional top view, you have to draw section lines which makes an angle of 45 degree with XY line, and all these lines are equidistant. So this is sectional top view, and in front view this is the remaining portion with us. So darken the remaining portion like this, and this upper portion can be erased or lightened like this. So draw it very much lighter or erase it, and this represents the front view, this represents the sectional top view. Similarly, you can name the points. Here point number 1 is there, here point number 2 is there, here point number 3 is there. So 1 dash and 2 dash would be here, point number 3 is here. Now what's about the true shape of this section? As the cutting plane is not parallel to XY line, here this top view will not represent the true shape. So to draw the true shape of this section, let me draw lines from the respective points in front view, say 1 dash and 2 dash, like this. These lines are perpendicular to this cutting plane, right? This angle is 90 degree. This is a cutting plane, and 90 degree at an angle of 90 degree to this cutting plane, draw the projection lines. Now measure the distance of the top view of these points from XY lines, like this. XY line to the respective points, say point number 1 to XY line, measure this distance, right? This one, measure this distance, take this distance as a radius, put it over here and draw an arc like this. So that arc will cut this vertical line at one point. So locate that point. This is point number 1, or P1 you can say. Then point number 2, so for point number 2, draw this arc, measure this distance, put it over here on 2, draw an arc, and that arc will cut on this line at point number 2, right? Now how to locate point number 3? Yes, for that also measure the distance of point number 3 in the top view from XY line, measure this distance, put it over here, and it will cut the vertical line from point 3 dash at this point. Here is 3 dash and here is point number 3. Now as it shows the true shape of the section, join all these points with a straight line in sequence. So 1, 2, 3 is the triangular shape, and as it's a true shape, draw section lines through this in this triangular shape, which makes an angle of 45 degree with the cutting plane line, not with XY line. As cutting plane line makes an angle of 30 degree, so 30 plus 40, 45, that would be 75 degree with XY line would be the angle of these true shape sectional views. So you can write the name of views as it's a true shape. You write the name of respective view, it's a true shape. This view represents front view, and this is sectional top view or sectional plan. And here scale 1:1 is used. You can write scale 1:1 because the dimensions are not much longer, much bigger or much smaller. We can draw this solid with 1:1 scale. Then insert the respective dimensions at least once in the diagram. So the side length is 50 millimeter. So here insert the dimension, the side length is 50 millimeter, like this. You can use the aligned system of dimensioning, 50 from here to here, and height is also 50 millimeter. So that also you can insert in the drawing sheet. And this problem is asked for 7 marks in the examination. So 2 plus 2 plus 3 would be the pattern for this solution. 2 marks for front view, 2 marks for sectional top view, and 3 marks for true shape of the section. I hope the solution of this problem is clear to you. Now example number 2. A cylinder diameter 100 millimeter and height 120 millimeter has its circular base on vertical plane. Its axis makes an angle of 45 degree with vertical plane. It is cut by a cutting plane which is parallel to VP and bisects the axis. Draw projections, sectional views, and a true shape of the section. Here a cylinder is given, and this example is little bit different than the previous examples. In the previous examples, it was given that the solid is resting on its respective base on horizontal plane. But here the example data is something different. Here it is given that it is resting on vertical plane, not HP. It's a circular base is on vertical plane, and the axis makes an angle of 45 degree with VP, which was given in previous problem with respect to HP. So here some different steps should be taken, and this solid is cut by a cutting plane which is parallel to vertical plane, not HP. So first in this problem we have to assume that this solid is resting on vertical plane, so its front view would be circle and its top view would be rectangle, which is different from than previous examples. This is a cylinder. Draw an XY line which represents intersection of both the planes HP and VP, and draw a circle above XY line of diameter 100 mm. Here the circle should be drawn above XY line. Why? Because it is given that the cylinder base is on vertical plane, not on HP. So if you look from the front, this for front view, the VP is above XY line, and insert the dimension 500 and draw its section lines or axis of this solid, and at a distance of 120 mm from XY line mark a point on axis and take projections from the end point of this circle and draw a rectangle below XY line. The width of this rectangle is 100 mm and height is 120 mm. That is the height of this cylinder. Now it is given that the axis of this solid is inclined at 45 degree to vertical plane. So what should we do? So it means that this rectangle, in this condition, this rectangle axis is making an angle of 90 degree with XY line, that is 90 degree with vertical plane. So we have to tilt this solid in such a way that this axis makes an angle of 45 degree with XY line. So draw a line at an angle of 45 degree to the right side of this front view, and then redraw this rectangle in such a way that this axis makes an angle